We're in Chapter 2, Lesson 7, Equations with Two Variables here. And what we have to do is write an equation that represents x and y on these tables here. What y shows me what something's happening to x and it's giving us y. Sometimes I've taught this as input and then the output is y comes out. So I have to write an equation here and then I have to find a missing value here. So let's take a look. It's going to be y equals something happening to x. Something happens to x to give me y. What happens to x? 20 to 10. Well, is it minus 10? That works for this example, but 16 minus 10 is not 8, and 12 minus 10 is not 6. But I can also notice that divided by 2, 20 divided by 2 is 10. 16 divided by 2 is 8. 12 divided by 2 is 6. So it's whatever x is, and that seems to work. Whatever x is divided by 2 is going to give me y. Give me something down here. Well, let's test it. Let's test our theory. So let's say, what's y if x is 8? 8. X divided by 2, or 8 divided by 2 equals 4. So y equals 4. Well, let's now find that works for that one, and I can test it for each of those if I wanted to. Now let's find our missing number. We have y equals whatever x is divided by 2. In this case, y equals 4 divided by 2. Y equals 2. So the missing number is 2. The formula is the formula is y. Y is my output. Y divided by equals x divided by 2. There we go. And there are 3 or 4 of these, and you just have to find the pattern and make sure the formula you come up with works. Plug in the numbers. See if you wrote the right formula or the correct formula. Just have to test it. So Amanda here is 7 years younger than her cousin. So who's older? Amanda or her cousin? Amanda's younger than the cousin. So I'm going to say A Amanda equals whatever the cousin's age is minus 7. And now let's just see if this makes any sense. So Amanda's 7 years younger than the cousin. If the cousin was 10, let's say 10, Amanda, how old is Amanda? 10 minus 7. Amanda would be 3 years old. Now, does that make sense? Go back. Does that make sense? Amanda's 7 years younger than a cousin who's 10. 7 years younger than 10 is 3. So 3, 4, 5, 6, 7, 8, 9, 10. 7 years younger. You can count it and check it with some simpler numbers. So A equals C minus 7. I've seen a lot of people write it the reverse way, but just if you plug in the numbers, and I were to plug in the numbers and I find out the way I have my equation written, Amanda turns out to be older, I need to rethink my equation. Let's go on. Here we have another one. 7 to 11, 8 to 12, 9 to 13. So I'm going to find y. What happens to x to give me y? Well, it looks like y is exactly 4 greater than x. 7, 8, 9, 10, 11. That's plus 4. 8 plus 4 is 12. 9 plus 4 is 13. So y equals, the output, or y equals whatever x is, plus 4. Okay, so let's test it. Let's test what's y if x equals 8. 8 plus 4 is 12. Y would equal 12. And what do you know? That works. That works, right? That works perfectly. You can test it for all of them. So let's solve it now. Let me write my equation. Y equals x plus 4. And then if x is 11, y would be 15. The missing number would be 15 right here. Okay? So just be careful and once again, just test it. Think, draw a pattern, come up with a plan, and test it. So the population of North Carolina is twice as large as the population of South Carolina. North Carolina is twice as large as South Carolina. So we did this in class. And somebody wrote, let's write S for South Carolina. South Carolina equals N times 2, or N2, or 2N. N times 2, or 2N. Let's see if that makes sense. Okay, let's use some smaller numbers. And in class, we use the example of New York, and y'all laughed at me when I tried my numbers, but let's just pretend North Carolina is twice as large as South Carolina. Let's just say that North Carolina had 10 people in it. What would South Carolina be? 20. 2 times 10. Well, does that make sense? If North Carolina had 10, South Carolina would have 20. Well, which one's larger? North Carolina's larger. So I'm on the wrong track. And the student who gave so we had an example in class that was sort of on the right track. So let's rethink this. North Carolina is, and look at that letter, is. So North Carolina is kind of like equals 2S, 2 times the size of South Carolina. And once again, let's say South Carolina had 10, North Carolina would have 20. If South Carolina only had 100 people in it, North Carolina would have 200. So it's South Carolina times 2 is going to give me North Carolina. And that is, you always got to look where that is, and that will help you out. So number 6 is N equals 2S, or N equals S times 2. I like to write it the algebraic way here. Okay, let's go ahead. Ooh, here we got a monster here. Henry records how many days he rides his bike and how far he rides each week. He rides the same distance each time. He rode 18 miles in 3 days, 24 in 4 days. So I can do my little chart. What happens to 3 to give me 18? Well, that's if I times it by 6. 24 times 6 times 4 is 24. 7 times 6, 4 times 6 is 24. 7 times 6 is 42. So I'm coming up with, let's see, the miles, the day, the miles equals the days times 6, or 6D. The days 6 times. Okay. So let's try it out. So if he rides 3 days, 6D, how many miles is it? Miles equals 6 times 3, I would get 18. M equals 18. It fits. So how many does he ride 1 day? Miles equals 6 times 1. For every day he rides, miles would be 6 miles. Okay? Miles equals 6 times D, or the days times 6. So in 3 days, 18. So just plug it in and it works. And that's double equations. We're going to graph these equations next time. So thanks for watching.